Hi, in this video I'm going to talk about Newton method. Newton's method has two applications for finding the roots of a function or for optimization, finding minimum or maximum of a function. So first application, finding the roots. Basically it's an iterative approach. It says approximate function like this with at the arbitrary point, and write the equation of the line that go through here. Set this equation to this line to 0. Basically, we are approximating this function with this line, and so okay, the 0 of this is going to be close to the 0 of this. So we start from this point here, and then we compute the line that go through this point x1, and we find the point that is the 0, that point that crosses this line, which is going to be x2, and then we continue from x2. So basically every point is previous point minus value of f over derivative, and it's pretty easy to see where do you get this. I just explained it. All you had to do is write the Taylor expansion for the your function, and only approximate with the first derivative. So your approximation of your function with this line is value of the function on that point plus x minus a multiplied by derivative on that point. So this is the equation of a line. If I set it to 0, you can see the x minus a f prime equal to minus fa. This goes to the other side, and I divide it by fa. So x minus a gonna be fa over f prime, and this is your new point. This is your old point, which is basically the equation that we had here. So it's an iterative approach, and just see where did we get this. If I want to use it for optimization, all you have to do is apply it on a derivative of function. So basically you took a derivative, you set it to 0, and apply just what we did here. So as you can guess, what happens is going to be every derivative that we have going to be 1 degree higher. So that was our intuition. Let's see. We approximate the function with Taylor expansion on the second, only up to second derivative. Then we took the derivative according to relative to delta x, and we set it to a 0. So if we take the derivative from this term, it's going to be 0. This is going to be f prime a, and power 2 multiplied by this is going to be 1. So it's going to be f prime plus second derivative multiplied by delta x. We set it to a 0, and the delta x is going to be f prime, sorry, there should be a prime, f prime over second derivative. So as you can see, the new x is going to be old one minus this term. And if you write it for higher than, this was for 1 dimension. If we have n dimensional function, we have to write it in a matrix form, and we know that for functions we have to write the inverse for division. If you want to divide something in a matrix, you just multiply by the inverse. And H is the Hessian matrix. As you know, it's if you look it up on the wiki, you can see the structure of H, which is the second derivative for every element. So the new point gonna be the old point minus inverse of this matrix, which is the Hessian of a function multiplied by gradient of x. Yeah, thank you.